All right. Hi, Shlomo.
Hi, Renee.
I wanted to start by asking you about your current status. You're a professor of computer science at Illinois Institute of Technology, right?
That's right.
And you're also the lead of the director of the Master of Data Science program there?
That's right.
And how long have you been doing that?
Well, the program has just entered its third year. So there's a year or two of running up and setting up the program, and this is now the third year of the program. We have 30 master students currently, with a fair number set to come in the spring, and it's growing by leaps and bounds, like data science generally.
Great. Okay, well, we'll come back and talk more about that program later. But first, I want to go back to your youth. I've been asking each of the interviewees, was there anything when you were a child that led you to believe that you were going to go into a field like this? Did you start out really good in math, or did you start programming early in life or anything like that?
Well, yeah, I've been interested in math and science generally since before I can remember, really. My father's an electrical engineer, so I get some of that both, I guess, genetically and also by nurture. And I was programming computers probably by the time I was 10 or 11, which in those days, which was more years ago than I'd like to admit, was not quite as common as it might be today. I think I'm probably one of the youngest people who learned to program a programming language on punch cards.
Oh, wow.
Which is quite an experience. And I was programming all through high school and taking classes over the summer at the local university in computer stuff. Although it was kind of a toss-up for me in high school whether I wanted to go into computer science or microbiology. Then when I hit my first lab, I decided computer science.
That's great. And so what were the undergrad and graduate schools that you went to?
So I went to Carnegie Mellon undergraduate. I did my bachelor's in applied math there, and I went to Yale for graduate school for my PhD.
Okay, and at Yale, you did a project, your dissertation had to do with robotic vision, didn't it?
Yeah, my dissertation had to do with both vision and map learning for mobile robots. So this is what I got.
Tell us more about that.
Sure. This was long before Roomba or anything like that. And a big problem then was, how can a robot know where it is in an effective fashion? Sensors can get it just so far. This was also before GPS, which helps to a certain degree, but not always even in buildings. So the question is, if you put a robot in a building that it doesn't know anything about, how can it at the same time build a map of its surroundings and also figure out where it is as it goes? If you think today, there are actually deployed rescue robots which go into collapsed buildings or mine shafts to help rescue teams, and these robots often are in situations where communication isn't really possible or feasible with the outside world. So they need to be able to figure out things on the fly. So
how do they do that?
Sure. What they do is they need to integrate information from different kinds of sensors, such as, for example, sonar to have some idea of where walls are, what objects are in the vicinity, vision to be able to recognize things, and then at future times you need to match those that incoming information with remembered information, and use statistical methods to probabilistically infer where is both to infer where the robot is, and then based on your inference of where the robot is, update a model of the environment, where the walls are, what kinds of objects are in the environment, and so forth. And the techniques that I was, the angle that I had in my dissertation research was in doing this without the robot doing a lot of active exploration. So it's much easier to learn a map of your environment if you can develop a strategy for exploring. I'm going to turn right, and then I'm going to go back, and then I'm going to go left, and then I'm going to go back, and I'm going to go back and forth to try to figure out what's in my environment. But to build an accurate map of one's environment while pursuing other tasks and not focusing on the learning task and choosing actions and movements in order to do the learning task, that's much harder.
Okay.
So that was really sort of the focus of my dissertation, what I call their passive map learning, and there are other terms that are used as well.
And if someone else wanted to go into research like that with robots, what are the most important classes that you took in college that made that possible?
Well, one of the most important classes, which I didn't realize that I was going to be doing this at the time, otherwise I would have paid more attention, was statistics. Learning probability theory, learning different kinds of probability distributions, learning statistics and statistical inference was very important. In particular, and this is something that they don't normally teach at the undergraduate level, Bayesian statistics. I remember particularly that when I took statistics as an undergrad, I found it very, very confusing and just kind of felt in my bones that it was just wrong in some way. And I didn't realize till I got to graduate school and started I needed statistical inference for my research. And then I learned about Bayesian statistical inference that I realized that, it's not that I don't get statistics, it's that I'm just naturally a Bayesian.
Oh, okay.
And from then on, I love statistics, at least the Bayesian flavor.
Yeah.
And that
okay, so go ahead.
Yeah, no, go ahead. Sorry.
Oh, so I was going to say, when was it during your college career, or was it later, that you decided that you wanted to teach?
I always kind of had an idea in my head that I was going to be a professor. Not quite sure where that came from. I didn't really think about teaching much. In fact, I know that in graduate school, I found that I really, really enjoyed when I was a teaching assistant. I really enjoyed working with students who would come to my office hours. The challenge of explaining complex technical concepts, which when you're used to them, they just kind of seem obvious.
Mm-hmm.
It's a real challenge to explain it in a way to somebody to whom they're new, in a way that they can understand. And I really enjoyed that challenge. I'm
also interested in learning about different learning styles. So how did the way that you learned it yourself, how did that inform you, and how did that compare and contrast to the way other students learn when you teach?
Well, I have to say honestly that I haven't really introspected all that much about my own particular learning style. What I've tried to do in my teaching, from my days in graduate school working with students, and then later on as I learned to be a reasonably good lecturer and so forth, I tried to look at the students and to try to understand where they're coming from, and to see what are the conceptual difficulties or issues that they might be having. And one of the strategies, I guess you could say, that I use in my teaching is to explain things in multiple ways. To try to find different angles for explaining the subject, to explain things, for example, if I'm explaining something mathematical, to show the equations and to show diagrams and perhaps even animations where appropriate, to be able to help the students to build some sort of intuition about the problem, while at the same time giving them the detailed exposition so that they can actually get into the meat of it. And does that make sense?
Yeah. Yeah, what are the key things that they tend to be missing or get hung up on as master's students that they could focus, undergrads now could focus on more before they get to grad school to help them in this area?
Well, I'll tell you, the one thing that I see in a lot of our students is the ability to deal with unexpected difficulties. And this is, this is it's not a specific technical area, but to be able to believe, in part, this is sort of a psychological thing. I know that this is not the expected answer, and this is not a specific subject that you need to study, but working and learning how to overcome unexpected difficulties. So, for example, to give just an example of this, if say I give an assignment that says, okay, here's a data file, read in the data file, load it into a database, and do some kind of analysis on it. And maybe the data file is in a CSV format. It's in a particular format, but there are some errors in the data file. So the standard load command doesn't work.
Mm-hmm.
Okay? You need to be able to say, okay, well, it doesn't work. Let me figure out what's going on, why it doesn't work, not just keep beating my head against the wall, but say, okay, well, let's look at the file. Let's try to figure out what errors might be in the file. Let's take a small piece of the file and try to load it in, see if that works. Different kinds of just general problem-solving principles of being able to have these kinds of heuristics or ideas to push through an unexpected difficulty. I mean, that's the sort of thing. I mean, in data science, we see this all the time. Data is never clean. Data is never perfect. There are always issues at all kinds of different levels. And we have to be able to get beyond that. And what I see in my experience, unfortunately, I think it's part of educational system sort of in part perhaps causes or encourages this kind of mindset, in that assignments in classes are very well defined, very clean, very perfect. So students know what the problem is that they're trying to solve, and so they solve that problem. In the real world, you get a problem, you're trying to solve problem A, but in order to solve problem A, you have to solve problems B, C, D, E, and F that you weren't counting on at all. So you have to have the confidence in yourself, have to have these kinds of problem-solving methods, general ideas on how to solve these problems to be able to push through that.
So for someone just starting out in data science, then it might be a good exercise to take what you just learned in a classroom setting or from a pre-cleaned data set online and try to do the same thing with a real-world data set that you just grabbed from the internet somewhere.
Absolutely. One of the things that I tell our students all the time is to spend as much free time as they have, which I know they don't have very much of, but to spend their free time doing things like Kaggle contests and stuff, and similar kinds of projects with real-world data. For exactly that reason, I would almost suggest that a great preparation would be for students, if they're people that have friends that are also interested in this, to team up and to have one of them try to mess up the data in some way, and for the other, not to tell the other student, and the other student to try to solve the problem, and back and forth. That would be kind of a fun sort of adversarial contest kind of thing to learn to deal with these kinds of weird things.
Great advice. So take us through a little bit of your career before, after you finished grad school, but before your current job. What were some of the key highlights of your career?
Well, when I got my PhD, as you mentioned, I did my dissertation in robot learning, machine vision, and learning from mobile robots. I then did a Fulbright at Bar-Ilan University in Israel, and getting funding to build a robot lab there was not a trivial task. Fortunately, I had an office mate who was doing research in natural language processing, and he suggested an interesting research project to me, and I said, okay, sure, let's look at that. And from then on, I've been doing research in natural language processing instead.
Oh, so just because the funding was available, you were able to jump on that right away?
Funding was not only more available, it's also less necessary. I didn't have to build a lab and machines and all of that kind of stuff. So it's a bit cheaper to get started. But but I love it. One of the things that I love about working in this field is that it's a very, very interdisciplinary. I'm using computer science and linguistics, and there's some philosophy, and of course cognitive science, logic, statistics, all of these things kind of coming together. And that's kind of like where I like to situate myself, just because it's just much more interesting to me.
Yeah, and I saw on your profile you have some really interesting natural language projects. So can you detail a couple of those for us? Sure.
Possibly one of the more interesting ones, and one of the ones that got me into my current line of research that I've been doing for the last almost 20 years, I guess, is a colleague of mine and I did some research looking at whether we could whether a computer program could use machine learning to distinguish between writing by men and writing by women. So could we figure out whether the author of an article or a book or a novel was a man or a woman? And it turns out that the answer is most of the time, yes. We can tell the difference between 70 and 80% of the time whether the author is a man or a woman, purely by the writing style. And we're not talking about what they're writing about. So certainly, I mean, there's all kinds of stereotypical correlations between what men write about and what women write about. But even if we say we took articles, if we took articles, say, all from Wired by male journalists and female journalists, we would probably be able to distinguish 70 to 80% accuracy between them, based simply on subtle differences in style of writing.
And did you look at whether that was dependent on culture, or is that across the board?
Well, to a certain extent, we can say that it's fairly culturally independent, actually, because the initial research that we did was looking at 20th century British English, both fiction and nonfiction. But since then, we've looked at 18th century French novels. We've looked at characters in plays. We've looked at late 19th century, early 20th century plays from the Caribbean. We've looked at characters in Shakespeare's plays, the male characters versus the female characters. And what we see is, first of all, that we can distinguish with approximately the same accuracy in all of these cases, and also that the features of the writing style are very similar in all of these cases. Now, what we haven't looked at, say, 12th century Chinese literature, or further afield. I mean, we're looking still sort of within a European, relatively recent European tradition. But it gives some indication that there may be some, if not universals, but at least some current breadth to this finding.
So with the Shakespeare part of the study, so those were all written by the same person,
right?
Well, theoretically, but
right.
So what if you were looking at the characters? What were you then distinguishing? So it was how he wrote each of the males or females,
right? What words he put into the mouths of the males versus the females.
and how does that differ from something written by a female?
Well, what was interesting is that the differences that we saw between the way Shakespeare's females talk and his males talk is very similar to the differences that we see between the way female authors in the 20th century write and male authors in the 20th century write.
Wow.
We see the same kinds of differences in features. We see that, to give some examples of the features, we see that men typically, and again, I'm speaking statistically here, so on average, men use more nouns compared to verbs, and they use more adjectives and determiners related to those nouns, which is to say that, to put it in a very overly simplified, stereotypical way, men talk about things and the qualities of those things. Women tend to write, and female characters in Shakespeare tend to talk using more verbs, more pronouns, and there are a few other categories of words that they use more frequently than men, which indicate that they're more putting the relationship between the writer and the reader, or the speaker and the hearer, into the context of the conversation.
Okay.
These two different styles have been called, an informational style versus an involved style.
Interesting.
Not our terms. And it seems to hold pretty consistently across different kinds of texts and different areas, as I've said. I can't really comment on why.
So what kind of programming languages or data science tools did you use to do those studies?
Okay, well, these studies, trying to remember, well, one tool that we've used a lot just throughout the years is Weka, which is a great tool for machine learning. I mean, now there are all kinds of other machine learning libraries that are incredibly useful. scikit-learn is a very, very helpful one in Python, and there are lots of others. At the time, we were building our own natural language processing engines to figure out things like parts of speech and so forth. And now there are libraries like NLTK or Gate, which give a lot of facility in these areas. There are lots of very useful tools these days. Python and so forth, in different languages.
And is that something that you teach the students at Illinois Institute of Technology?
Yeah, one of the courses that I teach a course in natural language processing where the students learn a little bit how to use these libraries, but also how to build the underlying techniques themselves. And they're typically working in either Java or Python. And we're pretty open about what kind of programming languages they use. We make sure that all of our students know Java. They all learn Python. R as well is very big, especially in our statistics classes. They use R for a lot of the work, and these are kind of very fundamental languages.
So let's talk about that program a little bit more. What are the different backgrounds of students coming in, and what can they expect to learn other than just the programming languages?
Right. Well, one of the things that we aim to have is we aim to have a fairly diverse student body. The majority of our students do come from computer science or applied mathematics and statistics backgrounds, but we also have a fair number of people with backgrounds in the science, in sciences like physics and biology. We have people with backgrounds in business. We have at least one person with a bachelor's in history. So we try to keep sort of a wide variety of backgrounds, keeping in mind that in data science, it's really important to be able to work with people from very different backgrounds, and also to bring all of the knowledge that you have to bear to the problems that you're addressing. Creativity is a huge factor in how you address a problem, and somebody with just a purely narrow technical focus is not going to be the most successful data scientist, because you have to have a certain amount of breadth and ability to sort of think outside the box, talk to people who are non-technical, and understand their problems and how you might be able to help them.
Yeah, and in your experience in industry and in teaching, what type of people really bring the most to the projects, or what students really seem to succeed the most? I mean, what are the key features that you identify and say, yeah, that's going to be a great data scientist?
Well, the program's only been around for 3 years, so I can't say 10 years out our students are doing X, Y, Z. So I can't really say that. I can't give you a data-based answer for that. I can give you some anecdotes, but not any data. There are really kind of two key factors, and they're not technical factors. One is, and I'm not being original in these observations. Other people have said similar things. Curiosity, interest in asking questions and saying, that's funny. I wonder what's going on here. That is a quality that enables people to really get down and find out interesting, novel, and important things. And the other thing is communication. And when I say communication, I mean primarily the ability to listen, the ability to hear what clients are interested in, and also to be able to sometimes hear what the clients are actually not saying. Because often what happens is somebody comes in with a data science problem and says, I'd like you to do this analysis so that I can improve my marketing or whatever it happens to be. But the real problem is a little bit different than what they think. And if the data scientist is able to talk and to listen to the client, they can often figure out that, well, they want me to do this analysis, but if I actually give them this visualization, it might be a little bit more helpful to them. So
yeah, I find that's true as an analyst too, that just understanding the problem rather than listening to what the person's saying, listening to what's the subtext of what they're really trying to get at is really important.
Exactly. What's the real problem here that they're trying to solve? Not the problem they're giving me, but their problem. And those students who are able and willing to do that, to sort of step outside their technical mindset and almost put themselves in the position of their client to say, okay, well, what would I want? What do I need? And then to come back into the technical and say, well, okay, here's what I can give them that might be helpful.
So what are some examples of projects that your students are doing that kind of emulate those real world situations?
Well, one of the things that we have in the program is a practicum, which is run over the summer. And these are projects that our students typically work in teams between 2 and 4 with actual industrial partners. So our partners usually supply data. They supply some problems sometimes more or less at different levels of specificity, and our students work to try to find useful insights in the data for our clients. So last summer, we had several interesting projects. One of them was looking at complaints about medical devices. And actually, nearly all of our projects last year just coincidentally had to do with, involved natural language processing, which, was good for me. And what the students did on this project is they looked at these complaints about medical devices and tried to find correlations between different kinds of devices, different manufacturers' devices, and the kinds of problems that arose with the devices. There was some trying to remember some specific insights that we got, but there was definitely some interesting stuff there, and the company is running with this to use this information both to feedback information to the manufacturers, so they know what are the areas that they might want to focus in on, but also for possibly consumer-facing information, so that consumers, if somebody, say, needs a hip replacement, different kinds of patients with different kinds of conditions or different demographics might want one kind of hip or a different kind of hip.
Okay.
Depending on who they are and where they're coming from. That's that one example of a project. Other projects that we've looked at is looking at say hotel or product reviews, and trying to summarize perhaps hundreds or even thousands of reviews on a particular product in a way that's useful to a consumer. So if you come to Orbitz or Expedia, and you see you're looking for a hotel, and you see there are 7,000 reviews for 20 different hotels. How do I make sense of all those reviews to get some idea of where I might want to stay? And first, I want to know, is it a good hotel or is it a bad hotel? But more than that, I have particular interest in what's important to me, and what's important to you might be very different. So I want to know, what are the reviews are saying that's relevant to me? So the question here is to be able to extract the information of, what are the different factors that people are evaluating the reviews, what are they saying about it, whether positive or negative, and then summarizing it in some way that gives useful information to the customer.
That sounds great.
Part of what the students did, they did some standard they used word clouds, which can often be very helpful. They produced little graphs showing positive versus negative overall averages over different facets. And then one of the more interesting things is to see how those ratings change over time. So seeing the trends, you can see, is the hotel on an upward trend? Is it on a downward trend? Maybe things look bad, but it's only just now that they're looking bad.
So could you tell, like, when there was a renovation at the hotel and things suddenly got better?
Well, in principle, I don't think we actually saw anything like that, but I think that in principle, that's the kind of thing that you'd like to be able to see. But looking at the trends, sometimes you saw something looked really good, but you can see that it's been improving in some cases.
Those sound like great projects for students. So I know you don't have that, they haven't been out for very long yet, but what are some of the initial types of jobs that your students are getting when they graduate?
Well, there's actually a variety of different kinds of jobs. We have some students who are working for really data science-oriented firms, like data science consultancies, working as data scientists, doing data preparation and analytics and so forth. We have students working for large companies that have their own analytics departments, like particularly in the insurance industry. I think the insurance industry is really growing in terms of their use of data scientists together with sort of more traditional actuarial analysis. And that's been a very fruitful area. And we actually have at least one student working for a manufacturing firm, which sees the use of data science to analyze. I think what they're mainly looking at is they're looking at their customer base to try to improve their product lines for their customers by looking at data both on the reliability of their products as well as who's buying what, when, and where, which I think is a great area for improvement.
Yeah. So is there any other research or any publications that in your personal history that you want to highlight that we didn't talk about yet?
Well, I think that first of all, in terms of my research, another sort of area, another area of recent work that I've been doing is in looking at metaphors in human language. One of the things, and this arises a lot in questions like sentiment analysis, which are very big areas for natural language processing in data science in particular, is the fact that lots of human language is not literal, it's not simple, it's not, that movie was good, that movie was awful.
Right.
But things that are more metaphorical, things like that movie deserves to be dropped down a well and forgotten about, perhaps. That might be easier to figure out that it's negative. But that's sort of language. And so I've been looking at the question of how can we get computers, first of all, to recognize metaphorical language, and then to understand what it means. And then there are multiple implications of being able to do that. One of them, as I said, is for better sentiment analysis, but also simply just to better understand documents.
Yeah, I would think that something like sarcasm would be really difficult.
Sarcasm is a hugely difficult problem. And I'm not even touching sarcasm yet myself, but we're going to get there. And there are people who are working on it. It's much easier if somebody says #sarcasm at the end of a tweet than you it's sarcastic. Very helpful when people do that. But yeah, sarcasm is a very, very hard thing. It's hard for people to do often. But being able to get at those sort of deeper layers of meaning in language is kind of a theme in my research. And in terms of the metaphor stuff, my approach is very, very data centric. The idea is we're building, as large as we can, huge corpora of texts to look at statistical patterns of which words and phrases go together with which other words and phrases. So, for example, to take an example of a metaphor, if you say, she's a really sweet kid. So that's a metaphor because sweet typically applies to food, not to people. Now, how do you know that? Well, if we take a huge corpus of English language and we look at all of the uses of the word sweet, we can see that it's often used for food and sometimes used for people. But even more than that, we see that there's a whole cluster of adjectives that go together that are used for food, specifically for taste of food, and many of them are also used for people. So we can find that there's this sort of metaphorical cluster: sweet, bitter, sour. I don't know what else. Other kinds of adjectives, and then a meaning starts to emerge from that, and then we see that tastes for food correspond to personalities of people. Right? And then you get an idea.
So you can start to figure out that sweet is good even when it's applied to something else.
Right, but not just that sweet is good, but it's saying something about the personality of this person. Not just this person is good, but this person's personality is good in some way.
Okay.
Right, and then you have a better idea of what it actually means.
That's really interesting. So you're using sentiment analysis along with the linguistics.
That's right. That's right.
Okay.
And another area that I'm very interested in, we've really only just started, this is sort of more on the educational side, haven't really published anything about this yet, is data science ethics. One of the things that we have in our curriculum and we're working on improving, in conjunction, Illinois Tech has a Center for Ethics in the Professions, which works both within our institution and with many other institutions to develop curricula for ethics and education in different professions, primarily scientific and engineering, but not only. And we're working with them to develop curricula for our students to think about ethical questions in the profession of data science well and properly. And I mean, as I'm sure you know, I mean, we don't yet have in data science a generally accepted ethical code for professionals, and it's hugely, hugely important because our clients depend on us to give them accurate and clear information in ways in that they can't really understand the assumptions that go into the models, the implications of those assumptions, the caveats that come along with different kinds of very technical or statistical assumptions or the algorithms that we use. We have to be able to explain these things to them, and they're relying on us, right?
Yeah,
so
definitely.
we need
And so much of
clear
that is
ethical
just
guidelines.
hidden.
That's right. That's right. So we have to. We have to be able to think clearly about these things and also communicate clearly about them. And we don't have the answers yet as to how to teach this or what principles should be applied. But I think it's very, very important, and we're looking at these issues.
Yeah, that's great to hear. I've recently done some reading on bias that can be introduced into algorithms. And I wrote a little article about, challenging data scientists to even think about these things. And like you said, be able to explain to your clients what biases could possibly be, included in the algorithms based on the data that was collected or how it was cleaned or how it's being assessed. So how do you talk about those types of things to your students? Even before there's a formal ethics class, how do you talk to them about bias in these data studies? Well,
what we've been doing so far, and we're very aware that this is not where we will be yet. This is just the beginning. We introduced them to some of these case studies of bias that have been reported and been written about, so they can see what the issues are. And we can also talk about, because they understand the statistics, we can talk about where these biases come from. And otherwise, the algorithm itself isn't biased, but because of certain underlying correlations in the data, bias comes out of it.
Right.
So the question is, so they should be aware of it. We talk about the implications of this bias, and we talk about different ways in which they might be able to recognize this bias and potentially correct for it. Of course, when you correct for one bias, you might introduce another bias. So there's a balancing act that has to be done. But the first and the most important step, and where we're starting, is to recognize issues or to recognize potential issues. That's kind of, I think, the key thing. And I think this ties back to something we were talking about earlier, which is the best data scientist is somebody who is very technically effective within their technical area, but can step out of it as needed, can see that there's a world beyond it. And the best technical solution might have implications beyond the technical problem that's being solved. And bias is a perfect example of this. And what we try to do to teach our students is to be able to recognize these kinds of issues and, as best as possible, to be able to address them.
That's great. I'm so glad to hear that you guys are teaching that in the program. Well, everybody, I have been talking to Shlomo Argamon, and he's the director of the Masters of Data Science program at IIT. And I want to thank you, Shlomo, for joining me today. This was really informative, and it gives both the perspective of the teacher and the student. So I'm really glad you could be part of our initial set of interviews for the Becoming a Data Scientist podcast. So thank you so much for joining me.
Thank you very much. It was a real pleasure.
All right. Goodbye.
Okay. Bye.